In this video, we'll be talking about functions of complex variables, and functions of complex variables are a little bit more complex than functions of real variables. So let's talk about the differences and how we're going to use them in the future. So first, a quick review of the complex plane. So this is the complex plane, which on the horizontal axis has real component of complex numbers, and on the vertical axis has imaginary component of complex numbers. So how to map things is, let's try to map 3 plus 2i. So that means we want to go 3 on the real axis and 2 up on the imaginary axis and plot a point there, and that's 3 plus 2i. Let's see how to map -1 minus 2i, for example. That means we have to go -1 on the real axis and -2 on the imaginary axis, and that's where -1 minus 2i will be. So now that we get a feel for how to plot things in the complex plane, let's just go over a few other basic things. So RE, which stands for real, and this whole thing is read real part of 3 plus 2i, and it is 3, which is the part without the i. Now, imaginary part of 3 plus 2i you might suspect is 2, and that is correct. It's the part with the i. But something important to note is that whether it's real or imaginary part of a complex number, the answer in the end you're going to get is always going to be a real number. Because when you have imaginary part of 3 plus 2i, you're not including the i, you're just taking the 2, just the part that's in front of the i. Okay, so that's important to note, which will be important in the example we're going to do. So now let's talk about domains and ranges. Like the real valued functions, complex valued functions do have domains and ranges, but they're a little bit more complicated, because with real valued functions, the domain would be something like 0 to 1 or 0 to 1 inclusive. But with complex functions, domains are sets. Remember, we defined a domain as an open connected set. So for example, let's just draw an arbitrary open set here. So the dashed line means it's open, which means not including the boundary, but including everything inside here. So what does this mean? This means for some arbitrary function, of which this is the domain, if you choose anything inside this set and you put it through the function, you'll get a complex number back. And what kinds of complex numbers will you get back? Well, you'll get back anything in the range. And the range is also a set. It doesn't have to be open like the domain, but nonetheless, it's a set. So what does this mean for us? This means if you take anything in the orange and run it through the function, you're going to get back something in the green. So let's say this, if you put it in, maybe you get this back. If you put this in, maybe you get something here back, and so on. So this is why we were talking about sets, because sets are kind of at the core of complex analysis, because they are the domains and the ranges of our functions. So let's just try to get a feel for it by solving out the domain and range of this function here. F of z, and z is often what we give for complex variables. So this is our independent variable z. F of z equals I times quantity 1 minus 1 over real part of z. So this looks a little bit scary at first sight, but let's try to work it out. So let's first try to work out the domain of this thing. So domain is what? This is anything you can put, any z you can put in here that will give you a complex number back. So the only problem we're going to get is if real part of z is 0, because then we'll have a 1 over 0, which is undefined, and that leads to problems. Any other complex number you put in here, the real part will not be 0, and everything will work out. So where is the real part of z 0 on the complex plane? If we draw a quick little complex plane, remember this is real, this is imaginary. At the origin, surely real part of z is 0. If we go up a little bit, up here on the imaginary axis, the real part of z is still 0 because we are not gaining any horizontal distance. And in fact, anywhere on the imaginary axis, the real part of z is 0. So we just quickly found out that the domain is all complex plane except the imaginary axis. Again, because if you choose anything on the imaginary axis, real part of z is 0, and we get undefined and not going to get something nice back. So we have the domain all figured out. Check. Range, a little bit more complicated, not that much more complicated. We kind of have to look at the function, what's going on. First off, 1 over real part of z is a real number. Remember, because we said that real or imaginary part of anything is real in the end. So 1 over real z is real. So far this is real. Now 1 minus that real, still real. Now I times that real number is now a purely imaginary number. Okay? So we found that this function, no matter what you put in it in the domain, it's going to spit out a purely imaginary number. So is there any restrictions on that? Is there some imaginary number that cannot be spit out? In fact, there is. Let's try to form I. Is I a possible element in the range of this? Well, let's just try to figure out. So if we want I to come out, what z must we put in? So we're trying to find the z we put in. Of course, we can cancel these two i's, so we have 1 equals 1 minus 1 over real part of z, and we're going to get 0 equals 1 over real part of z. Now, if we multiply both sides by real part of z, we get 0 equals 1, which it obviously does not. Therefore, with this contradiction, we find that I cannot be an element of the range of this. Is there any other complex number that cannot be in the range of this? The answer is no, because if we have any other thing like 2i, 3i, 4i, so on, then we won't have the 0 equals 1 problem, and it will be in the range. So this range, first we have to write is all imaginary numbers, because that's the first condition. This only spits out imaginary numbers, except I. So in a fairly short amount of time, we worked out the domain and range of this just kind of by looking at it. So you can look at other functions too and try to work out their domains and ranges, but the key thing this video is trying to point out is that domains and ranges are sets. And remember, a domain is an open connected set, and a range is just some kind of set. Okay, until next time.